Hi students, once again I welcome you all to my channel, Abrar sir classes. ಇವತ್ತು ನಾವು EMI Chapter ina Mutual Induction topic ಮೇಲೆ problems ನೋಡೋಣಪ್ಪ. Okay, this is part 2 of the video. I will teach you how to solve problems in just 45 seconds based on the topic what? Mutual Induction of Electromagnetic Induction chapter. Okay, now we'll see this first problem. What it is saying, a solenoid has how many turns? Okay, 2000. N is equal to 2000 tons of power. Okay, wound over a length of 0.3. L is equal to 0.3. Okay, the area of its cross section is, area is also given. How much? 1.2 into 10 to the minus 3 meters square. Around its central section, okay, a coil of, again we'll take this as N1, L1 and A1. Okay, now N2 is given. N2 is how much upon? 300 tons. Is wound. If initial current of 2 amperes in the solenoid is reversed in 0.25 seconds, then EMF induced. What is EMF induced? E is equal to, we know that E is equal to M di by dt. Di by dt. Understood. How to calculate the EMF induced in the coil? We know that first you have to calculate M. How to calculate M? M is equal to the formula for coefficient of mutual inductance. M is equal to mu naught into Np into Ns into As. Okay. And what is Ns? Number of turns in the secondary coil. And what is As? Area of the secondary coil. What is Np? Number of turns per unit length. Okay. Np is given by what? Np is given by what? Number of turns per unit length in the product. Okay. You can write LP. Understood. So I can write the formula for M as what? Mu naught, okay, into N1 by L1, okay, into, okay, according to this one, I can write M is equal to what? Mu naught into, okay, N1 by L1 into N2 into A2, okay, N1 by L1 into N2 into A2, right? And then this dA by dt will be there. Okay, now let us substitute the values. What is A2? Okay, if they are not given anything about A2, we should assume that A2 is same as what? A1 only. Okay, now what is change in the current? Change in the current, di is nothing but what? Di is nothing but final current minus initial current. Okay, final minus initial current, IF minus I initial. Okay, I initial. How much is the final current? If an initial current of 2 amperes is in the solenoid is reversed andre ಎಷ್ಟಾಗುತ್ತಪ್ಪ minus 2. Okay, minus initial andre that is equal to minus 4 amperes. Minus 4 amperes andre we'll take what? The magnitude of this one. Okay, di is how much? Di is minus 4 amperes. We'll take the magnitude. Mu naught andre ಎಷ್ಟಪ್ಪ? 4 pi into 10 to the power of minus 7. Okay, into L1 and the rest by L1, okay, divided by L1 is how much? 0.30 into N1 is given 2000 into N2 is how much? 300 into A2 is how much? 1.2 into 10 to the power of minus 3, right, into how much we got? If I take di, okay, magnitude 4 divided by how much is the time? Into time is how much? They are given dt is how much? They are given dt is how much? Dt is equal to 0.25 second. Okay, that I have to substitute here. 0.25. Now that comes around. No, slowly you simplify this one. Okay, I can write this as, see, I can write this as what? This I can write as 1 by 4. 1 by 4 ಮಾಡಿದಾಗ ಇದು 16 ಮೇಲೆ ಆಗುತ್ತೆ. ಓಕೆ 4 I can write this. Okay 4 into 4 into 4 ಅಂದರೆ ಎಷ್ಟಾಗುತ್ತಪ್ಪ? 4 into 4 into 4 is 64 ಆಗುತ್ತೆ. ಓಕೆ 64 pi okay into 2 into 10 to the power of 3 into 3 into 10 to the power of 2, right, into 1.2 into 10 to the power of how much? Minus 3 minus 7 is minus 10 divided by 0.3. Because I have written this 0.25 is 1 by 4. Okay, this has gone to numerator. Therefore, 4 into 4 is 16 into 4 is 64 pi. Okay, this is done. Okay, this is done. Okay, this is done. This is done. Okay, and this is done. Now remaining is 2 into 10 to the power of 3 ಬರ್ತಿದ್ದೀನಿ, 3 into ಇದೆರಡು ಆ್ಯಡ್ ಮಾಡಿದ್ದೀನಿ. Now that is equal to 6, 3 into 2, 64 pi into 2 into 1.2 formula. Okay, 2.4 into how much is 3 by 0.3? How much is 3 by 0.3? 3.3, 10 out. Okay, I can write this as what? Again 10. Okay, 10. This is done. 64. 2 into 1.2 ಅಂದರೆ 2.4 ಬರ್ತಿದ್ದೀನಿ ನಾನು, into this and this. Okay, I'm writing this as 10 into 10 to the power 3 plus 2 ಅಂದರೆ 5 ಆಗುತ್ತೆ. 5 minus 5. Understood? That is equal to 640 no 64 pi, let it be 64 pi only, into 2.4 into 10 to the power of minus 4. That is equal to how much is 64 pi? 64 pi is approximately, you can take it as what? 201. Okay, 201 into 2.4 minus 4. Okay, now okay, this is 64 pi ಅಂದರೆ ಎಷ್ಟು ಬರುತ್ತಪ್ಪ? 201. Approximately it is coming how much? 2 into 2 ಅಂದರೆ 4, which is the answer which is nearby to 4. Okay, that is 48. Okay, you are going to get what? This is how much? 201 into 201 into 2.4 ಅಂದರೆ ಎಷ್ಟಪ್ಪ? How much? You are going to get 201. Okay, 201 into 2.4 ಅಂದರೆ approximately how much you are going to get? 482.4 into minus. Okay, see, yeah, two answers are near to what? Two answers are near to here 4. That is, one is 4.8 with a 48 is there. You have to be careful. Okay, you have to be careful here. Now I can write the same thing as what? I can write the same thing as what here? 48 into okay 10 to the power of minus 3 Webers. That is nothing but how much? 48 milliwebers. Okay, I can write this as what? 48 milliwebers. Understood? I can write this as, because 48 okay into 10 to the power of 1 andre 48 milliwebers. Hope you understood this. This is just okay calculation part. You have to be careful. Once if you do this one, remember the formula, okay, and you can do it. Okay, this is 48 milliwebers is the right answer. Hope you have understood. Next problem we'll see what it is saying. The number of turns in two coils. Okay, let us say coil A and N1 ತಗೊಳ್ತೀನಿ 300, N2 is how much? 400. Okay, This is coil A and this is coil B and that Karnataka. Okay, this is coil B. They are placed close to each other. Coefficient of mutual inductance. Okay, M they have given. M is how much? 24 millihenry. Okay. If the current passing through the coil is 2 amperes. Okay. What is the current passing through the coil is how much? 2 amperes. In coil A and this one. Okay. M1 is how? Yeah, I1 is how much? 2 amperes. Okay. What you have to calculate? Then the flux linkage with coil B. What is the flux linkage in the coil B? Okay. What is the total flux linkage in the coil B? Will be equal to what? Will be equal to coefficient of mutual inductance into the current flowing. Okay, into the current flowing in the primary coil. That is it. Okay. What is the flux linkage with coil B? The total flux linkage with coil B will be equal to what? Mutual inductance into current flowing in the coil 1. How much is M they are given? 24. Okay. Milli 10 of minus 3 into I1 raised to the power 2. That is equal to, how much is the answer? 48 millivapors. Okay. 48 millivapers is the right answer. See, here also you are getting 48 millivapors and here also you are getting 48 millivolts you are getting here EMF induced. Okay, you have to be careful whenever milli is given and whenever 10 to the power minus 2, 10 to the power minus 5 and all those things are given. Okay, hope you understood. This is a very easy sum. Next problem will take up. What it is saying? It is saying two coils have a coefficient of mutual inductance they are given. M is equal to 0.005 to the power, okay, Henry. The current changes in the first coil according to equation I is equal to I naught sin omega t, where I naught is equal to 10 amperes and omega is equal to 100 pi radians per second. The maximum value of EMF induced in the secondary. How to calculate the maximum value of EMF induced in the secondary? Okay, what is the formula you have to use? You have to use what is the maximum value of the EMF induced? Okay, in the secondary they are asking you. Okay, the maximum value of EMF induced in the secondary, okay, is nothing but what? Is nothing but what? M into d IP by dt. Okay, always the maximum value of the value of the EMF induced in the secondary is given by what? Mutual coefficient of mutual inductance into the rate of change of, that is, current flowing in the primary coil. Understood? Now is equal to M into how much that they have given. How much is I is equal to, in the first coil, how much is IP they have given? Okay, they have given IP is equal to I naught sin of omega t to the power. Okay, now you have to differentiate this one. Okay, you have to differentiate this one. If I differentiate this one, how much I am going to get? That is equal to, okay, the d capital I, okay, dip by dt, and how much? I naught. What is different? What is differentiation of sin omega t? Omega cos omega t. Omega cos omega t. Therefore, M is equal to what? That is induced in the secondary is equal to M into I naught omega cos omega t. Okay, that is EMF induced in the secondary is given by so much. EMF in the secondary, I will term this as what? E. Now here, you know, E is equal to E is equal to E naught into cos of omega t. What is the maximum value of the EMF induced here in the secondary coil is M I naught omega. Okay, that is the maximum value of the EMF induced. Okay, that is the maximum value of the EMF. E naught is equal to M into I naught into omega. M is equal to 0.005. I naught how much they are given? I naught they are given 10 amperes. 10 amperes. And how much omega they are given? Omega they are given is what? See here, 100 pi. Okay, radians per second. You did not write, but I am writing here to make you understand. I naught is 10 into omega and the rest of 100 pi. 100 into pi. See the answer they are given in the form of what? Pi. So 0.005 into 10 into 100 and rest of the this will be 5 pi. Okay. What is the unit? Unit is volts. Unit is volts. Hope you understood. Just see this sum very clearly once again so that you can understand. Okay. EMF induced the secondary, okay, is M dip by dt. Okay, this you have to be very careful how to calculate the differentiation of, okay, IP. That is dip by dt is equal to I naught omega common. This gives the maximum value. Okay, this gives the maximum value. Like for example, E is equal to E naught, okay, sin omega t andre, okay. For example, this is the maximum value of the EMF induced. Ili anide mu M I naught into omega, okay, M I naught into omega, like that you can remember. Next problem, we will see what it is saying. It is saying that the mutual inductance between a primary and secondary circuit is how much? Mutual inductance is 0.5 Henry ಕೊಟ್ಟಿದ್ದಾರೆ. The resistance of the primary and secondary circuits are, okay, R1 how much? R1 they have given 20 ohm, R2 ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರಪ್ಪ 5 ohm ಕೊಟ್ಟಿದ್ದಾರೆ. Right. To generate a current of 0.4 amperes, that is in the secondary, I induced in the secondary, okay, I induced in the secondary ಎಷ್ಟಂತೆ? How many amperes? 0.4 amperes, okay. The current in the primary must be changed, okay. You have to calculate what current is, that is the primary, okay. dip by dt they are asking equal to how much? Understood. We know that what is E induced in the secondary. E induced in the secondary coil is given by the formula. Just now we have done M into what? dip by dt. But how much is E induced? E induced in the secondary. What is I induced in the secondary? Is given by I induced in the secondary is given by, okay, E induced in the secondary by what? By its resistance, that is R2, right? Therefore, how to calculate E induced in the secondary? E induced in the secondary will be equal to what? Just multiply. I induced in the secondary into what? R2. So this how much we are getting? I induced into R2 andre is to I induced is to 0.4 into R2 andre is to 5. Very good. M is 0.5. We do not know dip by dt. That's what they are calculating. They are asking us to calculate. Okay. So dip by dt andre ಏನಾಗುತ್ತೆ? 0.4 into 5 divided by 0.5. So 20 by 5 rest ಆಗುತ್ತಪ್ಪ 4 amperes per second is the right answer. 4 amperes per second is the right answer here. Hope you understood. You might have enjoyed the problems. If you have liked this video, kindly share with your friends. Subscribe for my channel. Ask doubts in the comment box. You like it if you are really liked it. Thank you one and all. I wish you all the best. Keep reading.